Welcome to Opportunity Crudes Management Seminar Series, an informative look at crude processing challenges. Disclaimers. The purpose of the OCMS series is to provide refiners with the latest information in processing opportunity or price-advantaged crudes, such as heavy sour oil, oil sand bitumen, light tight oil, and highly acidic crudes so that they can make better decisions in light of a volatile oil market. Video number 11, Solvent Deasphalting, BoB's Comeback Kid. Our previous seminar, video number 10, What About BoB, Bottom of the Barrel, discussed the various methods to upgrade heavy residue into more desirable products. The methods include traditional means, such as coking, VISBREAKER, and solvent deasphalting or SDA, and novel conversion processes such as resid FCC or RFCC, resid hydrotreating, and resid hydrocracking. The focus of this video, solvent deasphalting or SDA, or solvent extraction and deasphalting, involves the use of hydrocarbons such as propane, butanes, pentanes, or a mixture of these to extract light, paraffinic components from heavy residue streams and obtain useful products from bottoms. This diagram shows the products produced from each bottom of the barrel upgrading method. Today's video will discuss solvent deasphalting, which yield deasphalted oil or DAO and asphalt as products. The International Maritime Organization's or IMO's mandate of 0.5% sulfur for bunker fuel, which would take effect starting January 1, 2020, has prompted refiners around the world to install new solvent deasphalting units to reduce the bottom of the barrel fraction due to the diminishing sale of residual fuel oil or RFO. Solvent deasphalting, once a less desirable method to upgrade bottoms, is now likely making a comeback. This is in part due to the SDA process requiring less capital and operational cost compared to other bottom-of-the-barrel upgrading methods, and high demand for SDA products, which include specialty asphalts for road oils and roofing materials and lubricant products. Today's video will discuss solvent deasphalting in 7 sections. The first section, Solvent Deasphalting in the News, will cover the latest events involving refiners using SDA technology. SDA commercial technology trends and competition will present different commercial SDA technologies. DAO as feedstock for conventional FCC and hydrocracking will discuss the use of DAO as a feedstock for these purposes. Integration of SDA technology with other bottom-of-the-barrel upgrading methods will examine how SDA technology can be used to supplement other resid upgrading technologies. We will also share SDA unit operational experiences from refiners. Upstream application of SDA technology will discuss how a company's SDA technology can be used in the upstream sector. The conclusion of the video will recap how shifting fuel demand and key features of SDA technology may lead to renewed interest in solvent deasphalting as a popular resid upgrading method. Navigate oil market uncertainty and supply disruption in refining at the 6th Opportunity Crudes Conference in Houston, Texas in the U.S. from October 22 to the 24th, 2018. The theme of the conference is Crude Disruptors, Accelerating Changes in Global Refining. Higher oil output and refining price advantage. Domestic light tight oil has benefited international oil majors and U.S. independent refiners in the first quarter, respectively, according to just released earning results. Unfortunately, the good news will end soon as the oil market is going to enter an uncertain time since the price rout in mid-2014. A dark cloud is forming as driven by two formidable forces, geopolitical risks and changing supply-demand fundamentals. Change is not new in the refining world, but disruption of crude sources could significantly upset overall refinery operations in terms of crude management, processing, and product quality and volume. Our attendees will learn from conference speakers and network with colleagues on how refiners can navigate present market uncertainty and crude supply disruption by devising better business strategies, finding ways to increase operational flexibility, and adopting new technologies to turn challenges into opportunities. As in our previous meetings, this conference is expected to be highly productive and rewarding because of excellent speakers, timely theme, well-organized agenda, and stimulating atmosphere to encourage exchange of ideas. 5 topical sessions in 2.5 days include: Session 1, Global Oil Market Outlooks, Geopolitics, U.S. Pro-Export Policy, OPEC Strategies, Peak Demand. Session 2, Challenges and Opportunities in Oil Trading, Exports, Imports and Infrastructure Logistics. Session 3, Crude Contaminants, Incompatibility, Blending Strategies Amid Changing Feedstocks. Session 4, Flexibility of Light-Tight Oil Processing and Bottoms Upgrading to Make Products in Demand. Session 5, Big Data Analytics and Emerging Adoption of Internet of Things in Crude Selection, Management, and Refining. In this celebrated biennial meeting, you will meet colleagues from many companies around the world. The Opportunity Crudes meeting from October 22nd to the morning of October 24th is coordinated with Crude Oil Quality Association's fall meeting, which will be held on October 24th and October 25th to benefit from synergy in serving our upstream, midstream, and downstream colleagues. To save up to $300 before June 1st, register today by visiting OpportunityCrudes.com/Houston 2018. Here is a preliminary agenda for the 6th Opportunity Crudes Conference. Overall, SDA capacity in the United States has been increasing for the last 3 decades. According to the U.S. Energy Information Administration or EIA's Refinery Capacity Report, installed solvent deasphalting capacity in the country grew steadily since it kept the record in January 1989 when capacity stood at about 230,000 barrels per day. A recent peak was reported in January 2010 reaching 383,000 barrels per day before a steady decline to 368,000 barrels per day in January 2013. SDA capacity later rebounded and in January 2017 capacity recovered to 393,000 barrels per day. In 2018, ENI announced that its 220.9 thousand barrel per day refinery in Sannazzaro, Italy will have heavy oil output reduced to only 10% of total refined product output due to the additions of a new solvent deasphalting unit and slurry bed resid hydrocracking technology. In April of 2018, Chilean refiner ENAP licensed a 30,000 barrel per day residuum oil supercritical extraction or ROSE SDA unit at its 116,000 barrel per day BoB's refinery in the Concepcion region of the country. In early 2018, Finnish refiner Neste Corporation commissioned a new SDA unit at its 197,000 barrel per day refinery in Porvoo. In 2017, French oil major Total scheduled the startup of a 49.6 thousand barrel per day SDA unit at its 310,000 barrel per day refinery in Belgium, that would allow it to produce 10 parts per million sulfur diesel from high sulfur fuel oil. In 2017, to comply with the upcoming IMO sulfur spec, Shell planned to install an SDA unit at its 140,000 barrel per day Wesseling refinery in Germany that would produce DAO from vacuum residue to be fed into hydrocrackers or to be hydrotreated for further processing. Shell also invested in a new SDA unit in its 420,000 barrel per day refinery in the Netherlands that would allow DAO and asphalt production from a mix of crudes. This unit is expected to come online at the end of 2018. In 2017, Hyundai Oil Bank signed a deal with KBR to license a ROSE SDA unit with plans to have it come online in the second half of 2018. By licensing the ROSE unit, Hyundai Oil Bank will have the largest SDA unit in the world with a capacity of 80,000 barrels per day. In 2016, Thai Oil awarded a contract to UK-based AMEC Foster Wheeler to conduct front-end engineering design for its Clean Fuels project, which would include new SDA units. Earlier in 2016, China-based Hengli Petrochemical Company selected France-based AXENS to supply residue upgrading units, which include an SDA unit integrated with hydrocracking technology. In 2015, Japan-based JX Nippon Oil and Energy Corporation brought an 18,000 barrel per day SDA unit online at its Kashima refinery to produce pitch, which would be used as feed for a power plant. Solvent deasphalting technology can be flexibly applied in a number of areas in the refinery and for upstream heavy oil upgrading applications. Two primary features of this technology include the relatively low energy intensity and that an economy of scale is not needed, in which refiners are not constrained by the need to install large SDA units and can economically deploy this technology in both small and large capacity projects. As a result, solvent deasphalting can allow refiners to improve bottoms processing capacity without negatively impacting the energy efficiency of the plant with the addition of either a small or large capacity SDA unit. There are a number of commercial solvent deasphalting technologies available to be licensed. Today's video will discuss commercial SDA technologies from the following companies: AMEC, Foster Wheeler, UOP, AXENS, KBR, UD, and Well Resources. Note: discussions on Well Resources SDA technology will be shown later in the section Upstream Application of SDA Technology. In 1996, UOP and Foster Wheeler USA Corporation merged their solvent deasphalting technologies to jointly offer the UOP-FW USA solvent deasphalting process. Also licensed is SDA-RT, whose main feature is a step-out process that boosts DAO yield by 10 to 20% while maintaining the quality of the DAO for feeding to a vacuum gas oil hydrocracker. The company also licenses ASCOT, a process in which pitch production is eliminated by feeding SDA bottoms to the coker. Commercially, over 55 SDA units have been installed by Foster Wheeler and UOP prior to the collaboration, and several ASCOT units have been deployed. This figure shows a process diagram for AMEC, Foster Wheeler and UOP's SDA process. UOP's SDA process has proprietary structured packing internals for extraction column in fuels production, a rotating disc contactor for lubes production, and a 3-product configuration available. AMEC, Foster Wheeler and UOP also license SDA-RT, which uses a step-out process that boosts DAO yield by 10 to 20% while maintaining the quality of the DAO for feeding to a VGO hydrocracker. Other benefits include a 3-product SDA design, wherein the intermediate product is routed to a resin treating section to remove contaminants and reduce the molecular weight of the component, while the treated resin is then reprocessed in the SDA extraction section where it is selectively separated. The company also licenses ASCOT, in which pitch production is eliminated by feeding SDA bottoms to the coker. In this process, coke make is reduced compared to operating a SIDAC unit alone to treat vacuum resid. Furthermore, heat integration provides energy savings. AXENS offers his patent SOLVAHL SDA technology for processing heavy crudes. AXENS SOLVAHL has often been deployed in conjunction with its commercial resid hydroprocessing technology. Its integrated applications technology working alongside either commercial or conventional FCC and hydrocracking to limit pitch production. It has been reported that 13 SOLVAHL units are in use with total capacity reported at over 9.8 million metric tons per year, which is around 180,000 barrels per day. This figure depicts a process diagram for AXENS SOLVAHL process. This technology has a high operating temperature and low vertical velocity in the extractor. This process primarily uses C3 to C6 solvents. Heavier solvents, such as C4, C5 and light gasoline, are used to increase DAO yield. The DAO product has a metals content that is compatible with downstream operations, and part of the DAO product is pumped back to the extractor and strippers in order to preheat the feed to these units. Solvent recovery is in optimized supercritical conditions. Since 1995, KBR has been offering residuum oil supercritical extraction, or ROS, for refinery processing and heavy oil upgraders to process whole crude streams. Over 55 ROS units have been installed worldwide with a combined capacity of almost 1.3 million barrels per day. Aquaform is a patented method for storing asphaltenes, and has been successfully demonstrated using 3 different feedstocks in a 2-barrel-per-day pilot plant. This figure depicts KBR's The Product ROS process. KBR's ROS is deployed for refinery processing and heavy oil upgraders to process whole crude streams. Key features include supercritical solvent recovery and optional third stage to obtain a resin product, which can be hydrotreated. cracked or coked to yield more desirable products. KBR's ROSE flow is similar to the ROSE process but applicable for upstream projects to upgrade heavy oil and can be integrated with a steam generator where the asphaltene can be utilized as fuel for wells and reservoir facility. ROSE flow can also remove water and asphaltene while lowering viscosity. KBR's Aquaform is a low-cost option to handle asphaltenes by enhancing the ability to store and transport asphaltenes. UOP'S propane deasphalting is used for fuels or lubes production. The key benefit of this technology is in utility consumption for fuels production applications. A 720 metric ton per day unit was completed at a refinery in Poland. Here is a process diagram for UOP'S propane deasphalting technology. In a conventional refinery configuration, DAO from the solvent deasphalter is used to supplement feedstock to downstream processing units, such as the FCC and HYDROCRACKER, to augment the overall yield of transportation fuels. Optionally, it is possible to reject some of the paraffinic white oils in the resid boiling range that may be contained in the DAO by adjusting the recovery of DAO and processing the pitch from the deasphalter in a coker. In this configuration, FCC feed is augmented by coker gas oil. As shown in this table, to compare the impact of various streams on the FCC, workers from KBR presented experimental FCC yields from 3 different feed streams. In case study A, 100% vacuum gas oil, or VGO, 100% deasphalted oil, or DAO, and 100% coker gas oil, or CGO, were used. In practical application, the feed to the FCC is most likely 100% VGO or VGO augmented with some smaller quantity of DAO and or CGO. In case study B, KBR presented FCC pilot plant data comparing the use of 100% VGO as FCC feed to the use of a mixture of VGO and DAO as FCC feed. Generally, it was believed that Conradson carbon level is an indicator of FCC performance, but the results from both studies show that in a 100% and a 57% deasphalted oil stream, both of which had higher levels of Conradson carbon, had comparable amounts of FCC yield compared to a vacuum gas oil stream, which had less Conradson carbon. Instead, it was shown that FCC yield was correlated with C7 insolubles content. The VGO stream has more C7 insolubles content than the DAO stream, which did not contain any C7 insolubles. The most significant difference between VGO and DAO containing streams was in coke yield. Even though there will be a higher coke yield, processing DAO is still beneficial due to increased FCC feed. Alternatively, deasphalted oil can be used to supplement hydrocracker feedstock. In one case study, a ROSE unit was implemented to process vacuum resid. The deasphalted oil from the unit was then combined with vacuum gas oil and routed to a hydrocracker, which has a low conversion and a high conversion mode, depending on the desired gasoline to diesel production ratio. When more gasoline is desired, the low conversion method is employed and a significant amount of the vacuum gas oil and deasphalted oil remains unconverted in the hydrocracker and is routed to the FCC. In the high conversion mode, a larger percentage of the vacuum gas oil and deasphalted oil is cracked to liquid products in the hydrocracker, reducing the feed sent to the FCC. This table shows the results of the case study, showing the weight percents of FCC feed, naphtha, kerosene, and diesel of the FCC products from 2 identical feeds at low and high conversion modes. With the low cost and versatility of SDA units, they can easily be integrated with other processing units. Benefits of integrating SDA units with other processing units may include reduced carbon footprint and enhanced control over product quality. The size and placement of the SDA unit depend largely on current refinery configuration, feed processed, and desired product slate. Solvent deasphalting can be integrated in a number of flexible configurations with a range of refinery processing units that treat the high-quality DAO, intermediate quality resin, or low quality pitch, such as the coker, VISBREAKER, gasifier, resid FCC, resid HYDROCRACKER, etc. Solvent deasphalting technology is most commonly integrated with delayed coking technology. In this configuration, asphaltenic pitch from the SDA unit is routed to the coker unit to enhance liquid yields and produce petroleum coke. The configuration is especially attractive if fuel demand is low or non-existent. In a grassroots refinery, the cost of using integrated SDA and coking technology is about the same as installing just a delayed coker large enough to process the bottom stream, but the integrated option reduces operating cost and coke make while enhancing liquid yields. Additionally, the implementation of a solvent deasphalter to be integrated with a coker offers an attractive revamp opportunity if the coker serves as a bottoms processing bottleneck. A solvent deasphalted with a delayed coker requires a heater capable of minimizing peak heat fluxes to achieve the desired heater run lengths. Online steam spalling should be available to partially remove coke deposits from tubes and lengthen the time between turnarounds. This table shows properties of liquid products and residual components from a case study comparing the operations of an integrated SDA-COKER scheme to a plant with just a coker and a plant with just a solvent deasphalter to upgrade vacuum resid streams. Note: the properties of the liquid products produced by each of these three configurations are based on the vacuum residue of a heavy Orinoco crude. At a past American Fuel and Petrochemical Manufacturers Q&A session, refiners discussed their experiences using solvent deasphalter bottom streams as coker feed. ABB Lummus Global used a feedstock of vacuum resid blended with 30% asphaltenes and observed accelerated fouling in the preheat train and coking in the furnace, 10% higher coke production, and distillate products with higher specific gravities. Foster Wheeler UOP used a feedstock of neat solvent deasphalter bottoms and observed coke yield nearly equivalent to Conradson carbon residue content, slightly lower liquid yields, and higher gas yields than predicted using vacuum residue feedstock. M.W. Kellogg, with a feedstock consisting of rose asphaltenes, observed coker yields similar to those produced when using virgin vacuum residue feedstock. The integrated operation of visbreaking with solvent deasphalting presents additional opportunities for refiners to improve energy efficiency with heat integration. The solvent deasphalter bottom stream can be processed in a visbreaker, reducing the amount of cutter stock needed to meet fuel oil specifications and producing additional cracker feedstock. Alternatively, when an intermediate resin stream is taken from a deasphalter that is located downstream of a visbreaker, the opportunity exists to recycle some of the intermediate range components back to the visbreaker, which may result in the overall increase in liquid yields as more of the heavy components in the resin feed are thermally cracked to valuable liquids. According to KBR and Shell, positioning the visbreaker prior to the SDA unit is preferable as the SDA unit can be smaller, and therefore less capital intensive to build. The two companies have discussed offering the integration of visbreaking and SDA in the first quarter of 2018. Asphaltenes can be processed in gasifiers to produce steam, power, hydrogen, and chemicals, which was a scheme used by an Italian refiner to produce approximately 510 megawatts of power. The integrated operation of a deasphalter, coker, and gasifier can be used, resulting in similar increased liquid yield and reduced coker capacity as in an integrated SDA delayed coker scheme, but coke can be sent to the gasifier to produce steam, power, hydrogen, and chemicals. The implementation of a deasphalter, coker, and gasifier in one plant will essentially eliminate fuel oil and coke production from bottoms processing, concentrating the very high Conradson carbon residue materials into an even smaller quantity of slags from the gasifier. Furthermore, the concentrated carbon dioxide stream coming from the gasifier makes a good candidate for carbon capture, enhancing environmental performance and process economics. Using the solvent deasphalter bottoms as hydrocracker feed has been explored. Joint testing between two companies found that high-quality fuel oil can be produced. Another company found that bottoms from an SDA unit can be fed to a hydrocracker, resulting in 73% conversion of NC5 insoluble asphaltenes. Also, solvent deasphalting technology has been applied as a product treatment and recycle option for slurry phase hydrocracking processes. With this method, the quantity of pitch produced will be significantly diminished by recycling the light and intermediate streams back to the resid conversion unit. Resid hydroprocessing of DAO is also most commonly used to prepare feed for the FCC or hydrocracking unit. In general, extra heavy opportunity crudes contain up to 50% residuum content, compared to only 10% residuum content in conventional light, sweet crudes, with the molecular composition of the residuum content varying significantly among heavy crudes. Refiners have had mixed experiences with certain types of crudes increasing the carryover of asphaltenes to the DAO. Murphy Oil processes a variety of crudes and has observed differing yields of deasphalter bottoms. The company has not correlated an increase in carryover with a particular type of crude. Ultramar Diamond Shamrock has experienced carryovers of 400 to 600 ppm of asphaltenes to DAO, which they have attributed Venezuelan crude fouling feed filters in the downstream hydrotreater. KBR found that specific crudes, which include Minas, Robbie, Dutch Incorporated, Zerzatine, and Santa Barbara, have a propensity for asphaltene carryover, and that operational adjustments, such as changing the solvent to feed ratio, raising the resid cut point, raising the extraction temperature, and cycling a portion of the asphaltenes back to the extractor, can lessen asphaltene carryover. Hydrogen sulfide from vacuum residue feed and makeup solvent may accumulate in the circulating solvent. The accumulation of hydrogen sulfide can corrode equipment, lower solvent strength, and necessitate lower temperatures and higher pressures to achieve the desired performance. Operation of the vacuum tower impacts hydrogen sulfide levels in the circulating solvent because hydrogen sulfide can enter the unit dissolved in the vacuum feed when processing feed with very sour feedstocks. Ensuring the vent valves are open to allow suitable purging from the plant is considered to be a sufficient control mechanism. Purging a portion of the solvent, such as from the solvent drum in the recovery section, can control hydrogen sulfide levels. Treating a slipstream of solvent can be done with caustic or amine if a prohibitive amount of solvent were to be purged. The question of which types of indicators work well with asphaltene separators was raised at a past American fuel and petrochemical manufacturers Q&A session. One representative said that indicators and controllers based on a ball float mechanism have an established history of successful use in this application, and that these indicators are backed up by a series of tri-cock nozzles and valves arranged vertically on the side of the vessel to span the expected range of the fluid level. Another attendee reported the successful use of a differential pressure gauge with one tap at the bottom of the tower and the other above the expected level of the fluid, with the taps fitted with oil purges to prevent plugging. A third attendee said that switching from a ball flow to a transducer indicator made it easier to make level measurements in the strippers of the flash tower. Well Resources, in conjunction with the China University of Petroleum in Beijing, has developed the SELEX process for selective extraction of asphaltenes from heavy crude feedstocks, such as Canadian oil sands bitumen. The selective deasphalting process is suitable as a process unit in an upstream heavy oil upgrader plant to produce asphaltene-free refinery feeds. These asphaltene-free feeds can be more easily transported via a pipeline. Here is a process diagram of Well Resources' SELEX process for selective extraction of asphaltenes from heavy crude feedstocks. Here is our sponsor's experience. Selective extraction of asphaltenes, commonly referred to as SELEX, is a premier solvent extraction process licensed worldwide by the Canadian company Well Resources, through its partnership with the China State Key Laboratory of Heavy Oil Processing. Well Resources leverages over 30 years of research in complex petroleum chemistry and solvent oil interactions using state-of-the-art analytical methods. Asphaltenes are known to cause operational issues such as equipment fouling and catalyst deactivation. Dealing with these problematic components is a top priority for refiners. The novelty of SELEX is its unique ability to selectively remove asphaltenes from the bottom of the barrel as solid granules, which maximizes DAO yield. In contrast with conventional SDA processes that utilize liquid phase extraction, the SELEX extractor is operated at supercritical operating conditions, where the system exhibits vapor-solid phase behavior and allows for asphaltene precipitation. When asphaltenes are removed as solid granules, they are easily handled and do not require secondary processing to reclaim value, as compared to the heavy raffinate or pitch produced by other processes. This vastly improves the economics of processing heavy fractions. SELEX is a low-complexity and affordable option for adding processing flexibility to your refining operations. It replaces the need for operating complex and expensive ebulated bed hydrocrackers and cokers. SELEX can also be used in the midstream space as an economic alternative to upgrading. As of April 2018, 5 commercial SELEX units have been commissioned in Asia with individual processing capacities up to 20,000 barrels per day. An additional unit has been licensed in North America for treating Canadian bitumen. Operators often use SELEX to produce DAO suitable for hydrotreating. Desulfurization of this DAO allows for the production fuel oils that meet the low sulfur content specifications mandated by the upcoming IMO 2020 regulation. In one instance, a SELEX operator reconfigured its operations to process FCC slurry oil for the production of needle coke, a high-value, high-purity carbon product used primarily for electrodes in the metallurgical industry. These examples showcase the processing flexibility that SELEX offers. To learn more about this technology, contact info@wellresources.ca or visit www.wellresources.ca. The demand for residual oil in some regions around the globe is on the decline as a general shift to lighter distillate products has been observed, resulting in diminished demand for fuel oil and bunker fuels. As demand for residual fuel oil is diminishing, worldwide demand for light distillate products is continuously rising. The refining industry has responded in kind with an increase in bottoms conversion capacity. As bottoms conversion capacity increases, the supply of transportation fuels will inevitably increase while fuel oil production is limited. Solvent deasphalting, once considered a less desirable method for upgrading bottoms, may be making a comeback. Refiners looking for alternative market outlets for products derived from the residual cut of the crude barrel may want to consider SDA products, which include specialty asphalts and lubricants. The potential to install SDA equipment exists where refineries are exploring to increase their product yield with limited capital. Furthermore, novel process configurations and plant strategies may result in continued interest in solvent deasphalting technology. Thank you very much for watching our video. Please join us in June for our next seminar, video number 12, What's Coking? Thank you to Baker Hughes GE and Well Resources for sponsoring this video. Sponsorship opportunities are still available for the rest of the seminar series. Please contact Matt Wonder at mwonder@hydrocarbonpublishing.com to sponsor a future video. Sign up today to receive our quarterly technology newsletter, Worldwide Refinery Processing Review. This paid subscription has served the refining industry around the world for 20 years. Since it was launched in 1998, the review has become the most authoritative and comprehensive publication of the latest refining technologies around the world. The review monitors commercial technology developments and competition, plant operation improvements and troubleshooting, and R&D trends for all processing units, from the front end to the back end, in a single source. Each issue covers 2 technology topics with the following sections: market and technology trends and opportunities, state-of-the-art technology, plant operations and practices, refining R&D alert, worldwide installed capacity, recent construction activity and completed construction projects, latest refining technology developments and licensing. As shown in the table, this year's subscription will cover 8 topics, 2 in each quarter. Apart from an annual subscription of the review, individual quarterly issues and individual technology topics are also available for purchase. For more information, contact us at review@hydrocarbonpublishing.com. Your comments are appreciated. Please send your comments to info@opportunitycrudes.com so we can enhance the value of upcoming seminars. Here are upcoming crude oil quality events. Disclaimers.